Hi, in this video we are going to talk about linked list data structures, so let's get started. What are linked lists? Linked lists are composed of nodes and references or pointers pointing from one node to the other. Of course, the last reference is pointing to a null, and basically it's very important because this is how we are able to detect that the last node is pointing to a null. So in this situation, the first node is the node 1. It is pointing to the node 2, it is pointing to the node 3, it is pointing to the node 4, and the node 4 is the last node because it is pointing to a null. So basically it's very important because this is how we are going to implement linked lists, that we are going to iterate through until the next node is a null. So basically this is how we are able to detect that it's going to be the last node in our linked list. So what about a single node? A single node contains two important items. First, the data itself. It can be an integer, it can be a double, or it can be a custom object, whatever. And it contains a reference or a pointer pointing to the next node in the linked list. Of course, if it is the last node, it's going to point to a null. So if we would like to implement the node class, whatever in Java or Python or C++, we have to create a node class. And basically in the node class we can have everything we want, but two important features we have to include: the data we would like to store and the reference to the next node. It's going to be a node, of course. So each node is composed of a data and a reference to the next node in the sequence. It is a simple and very common data structure. Linked lists can be used to implement several other common data types such as stacks or queues. It's very important that simple linked lists by themselves do not allow random access to the data. We have been talking about arrays, and we have pointed out that the most important feature for the array is the random access. So we are able to get the items according to the indices. In this case, we do not have any indices at all, so we cannot use these indices. So the get item according to the index cannot be implemented. And many basic operations such as obtaining the last node of the list, or finding a node that contains a given data, or locating the place where a new node should be inserted require sequential scanning of most or all of the list elements. So basically we have to iterate through and visit all the nodes in the linked lists in order to find an item, for example, or remove an item or something like this. Of course, if we are manipulating the first item of the linked list, unlike arrays, it's going to be very fast. So what are the advantages for linked lists? Linked lists are dynamic data structures. We have been considering arrays, and we have come to the conclusion that arrays are not that dynamic. We have to specify the size of the array at compile time, and we have to specify that what kind of data we would like to store at compile time. So they are not dynamic at all. Linked list can allocate the needed memory in runtime, so they are dynamic in this sense. It is very efficient if we want to manipulate the first elements. It's going to take ordo 1, so constant time complexity, to insert an item at the beginning or remove an item from the beginning. We have been discussing arrays, and we came to the conclusion that it has an ordo n, so linear time complexity, to insert items at the beginning or remove items from the beginning of the array. And what's very important, basically it is true for arrays, that it's very easy to implement the linked list. Linked list can store items with different sizes. It's very important. An array assumes every element to be exactly the same. So that's why I say, although I don't want to repeat myself over and over again, that linked lists are much more dynamic data structures than arrays. And it is easier for a linked list to grow organically. An array size needs to be known ahead of time or recreated when it needs to grow, and this reconstruction of the array takes ortho and linear time complexity. Here, for linked lists, we are able to add a new node. Basically, we just have to update the references, the pointers, and it can be done in ortho 1, so constant time complexity. What about the disadvantages for linked lists? It wastes memory because of the references. As we have discussed, every node contains a reference to the next node. It's going to be the pointer basically, and of course, it's going to consume lots of memory. So, it's going to waste memory because of the references. Nodes in a linked list must be read in order from the beginning, as linked lists have sequential access. Array items can be reached via the indices in constant time complexity, but here for linked lists, we are not able to use random access, so we have to use sequential access instead. Difficulties arise in linked lists when it comes to reverse traversing. So single linked lists are extremely difficult to navigate backwards, and the solution is the doubly linked lists, when basically we store a reference to the next node and we store a reference to the previous node. It is easier to read, but memory is wasted in allocating space for a back pointer. It's very important then for arrays, we don't have to store a reference to the next item or the previous item. So in this aspect, arrays are very memory friendly. For a linked list, we have to use at least one pointer pointing to the next node. But when it comes to doubly linked list, we have to use double references, one reference to the next node and one reference to the previous node. But it's going to be easier to read the data and make any other operations. So that's all about the advantages and disadvantages of linked lists. In the next video, we are going to talk about the operations concerning linked lists. Thanks for watching.